Hello, this is a short video on solving radical equations. Now, I've chosen 3 problems that are very much like the problems that you will see on your test on Friday. So, make sure that you take notes, pause when you need to, and make sure that you understand every step. If you have any problems at all, or any questions at all, email me with your specific question and I will answer. And don't forget that I have tutoring on Friday morning before school. Now here are the steps to solve any radical equation. You isolate the radical. That means that the only thing on one side of the equation has to be the radical. Now there is one case where that is not true, and we will go over that in one of the examples. After you isolate the radical, you raise both sides of the equation by the power of the index. In other words, if it's a square root, you're going to raise both sides of the equation to the power of 2. If it's a cube root, you're going to raise both sides by the power of 3, and so on. Then you solve for the variables, and last, don't forget to check your answers for extraneous solutions. A lot of you forgot to do that on the quiz and lost points because of it. So here is the first example. Well, we're going to follow our process. We're going to isolate the radical. So I'm subtracting 7 from both sides of the equation, and I end up with one radical, the square root of 3t minus 3, on the left side of the equation. Now it's a square root, so I'm going on to step 2. I'm going to raise both sides of the equation by the power of 2. Now don't forget that when you are squaring a binomial such as t minus 7, you have to distribute or FOIL. So I end up with a quadratic on one side of the equation. Now it's time to solve for my variable. Now you know that to solve a quadratic, you need to set one side equal to 0. So I am going to move everything over using inverse operations to one side of the equation, and I end up with a quadratic. Next, I'm going to factor my quadratic and solve each of the factors. And when I do that, I end up with t is equal to 4 and t is equal to 13. And very important, I do need to check every answer, whether I have more than one answer or just one. It's possible that there are no solutions or just one solution. And so I am going to substitute my answer back into the original equation and see if it works. I see that the value of 4 gives me 10 is equal to 4. Well, we know that's not true, so that's an extraneous answer. And I will not circle that or indicate in any way on my paper that that is a valid answer. When I try 13, I find out that the equation works. So that is the only solution to this equation. So let me quickly review what I did. I isolated the radical. Then I raised both sides to the power of 2. I solved for the variable. And if you end up with a quadratic, you can bet your bottom dollar that it is factorable. So keep trying until you find the factors. Set each factor equal to 0 and solve for the variable, and then check your answers. My next example, I have a radical on both sides of the equation, and when I notice that I have 2 times the cube root of x minus 5, but I really can't isolate both radicals, so I will go to the next step, which is raising both sides by the power of the index. In this case, the index is 3. It's a cube root, so I will raise both sides to the 3rd power. Now, a lot of you made this mistake on the quiz. When you do this, you need to raise the coefficient of 2 to the third power as well as everything else. So when I do that, 2 to the third power is 8. Now, it was 2 times the entire square root of x minus 5, and so I end up with 8 times the binomial x minus 5. Don't forget those parentheses. And on the other side, it just got rid of the cube root, so I end up with just x plus 2. Now is the easy part. I solve for the variable, and so I'm going to distribute 8 across x minus 5, and then I am going to add 40 to both sides and subtract x from both sides. I end up with 7x is equal to 42, and from there it's very, very easy. I just divide both sides by 7, and I get the answer of 6. Now, it looks like it would work, but please check every answer. And so I will substitute 6 in for the variable and make sure that this equation works. And in this case, it does. And so 2 is a valid answer, and I can circle or box that in on my paper. The last example, I have a fraction for an exponent. I have 3x plus 1 raised to the 3 over 2 power. Now, in this case, I don't have any isolation I need to do, so I can go to the next step. When you have a fractional exponent, you simply raise both sides by the reciprocal of the rational exponent. My exponent is 3 over 2, so I'm going to raise both sides of the equation to the 2 over 3 power. Now, on the left side of the equation, that just gets rid of the exponent, and I have 3x plus 1. On the right side of the equation, I use my calculator, and I find out that 64 raised to the 2/3 power is 16. I have a nice, easy equation now to solve for x. I do that, and I check my answer. This answer checks out perfectly. Now, I want to go over this again because a lot of you did miss this or got confused about this on the quiz. If you have a fractional exponent, you raise both sides by the reciprocal. You flip the fraction and raise both sides. That gets rid of the exponent on both sides. And then you proceed. It's usually a pretty easy equation to solve after that. Now, I only gave you 3 examples because I wanted to give you examples that were similar to things that you would see on the test. If you have any questions at all, write down these examples or go find examples that are similar on the review, or both, and take them to see a teacher tomorrow on Thursday before or after school, or if you have to, you can wait until Friday morning. That's a little late, so I encourage you to either email me with your specific question. A photo of your work would be very, very helpful in answering your question, or see me on Friday morning. But it's best if you see someone as soon as you can tomorrow. Over and out, and I will see you on Friday.